Good morning. I am Reggie, Associate Professor, Department of ECE, Rogani College of Engineering and Technology. Today we are going to see about the topic implementation of Internet of Things with Python. Implementation of Internet of Things with Python. On completion, students will be able to know the level of implementation of Internet of Things with Python, implementation of IoT with Python. Implementation of Internet of Things with Python. Generally, prototype or real-time Internet of Things system have been designed and developed swiftly and competently. Whenever this occurs, two activities instantly come to life. One is the program, the IoT device, and other is to organize a backend of interact with the device. In both activities, we can utilize the Python programming language for their development, or we can utilize a functional and practical edition of MicroPython in order to work on device with small computing resources and accordingly at a very low price. We will understand the use of Python in programming IoT device and create a backend for them to work. Why we use Python as IoT? For many developers, Python is considered as a language of preference in the market. It is simple to learn, as clean syntax, and have a large online community supporting it. Python became a great choice when it comes to IoT. We can either use of the backend side of development or software development of device. Moreover, Python is available to work on Linux device, and we can make use of MicroPython for microcontroller. Python is a coding language that can be used to reduce the volume of data that can be used to deal with accessible in the cloud. Python recognizes the need regardless of whether we can create the IoT project from scratch or interact with actuator, sensor and accessories. Some of the benefit of working with Python for IoT device are large number of libraries for the type of platform and the speed it offers can develop the code. Python is generally early for developing diverse prototype. Even if you see some rewrite some of the script for producing C, C++ or Java to improve performance, the system will generally function perfectly in Python. Some of the best solution for IoT in Python programming are Python on Raspberry Pi, Python on PyBoard, ESP8266, ESP32 with MicroPython. All one by one we can discuss in detail how a controller, how we can interact with the sensor and actuator. Python on Raspberry Pi. The primary objective of running a Python on IoT device that pop-up mind is grabbing the Raspberry Pi from the table. Python is installed in operating system and the only objective left for us to write the code script. In this scenario, we can control the I/O port on the expansion bar of the Raspberry Pi. Fortunately, the board supports wireless communication and Ethernet. We can connect a monitor to a HDMI output and specialized TFT LCD or low power consumption for Raspberry Pi. There are controllers available in large number of computing power and budget. We can choose the a controller for IoT system ranging from fast Raspberry Pi model 8 GB to smallest Raspberry Pi Zero, all supporting Python programming language. In case of necessity, we can install the earlier version of Python 2 for fast compatibility. Let us consider the snippet of Python code whether we have to GPO0 order in order to control the IO port. Example, importing the record module from GPy0 import model from time import sleep. Creating an object of button, the button of 2 using the if else statement. While true, if the button is pressed, print button, press else, print button and sleep. How the above example demonstrate the receiving and processing of signal by pressing the button on the second pin at the moment of release. The benefit of utilizing this approach are the availability of large variety of development utilities, library and communication for most complex devices such as Raspberry Pi involving video processing from camera. Python and PyBoard. Another great solution for Python and PyBoard is with STM2F405 RG microcontroller. The PyBoard is considered a compact as well as powerful electronic development mode. It works on MicroPython. The PyBoard connects to PC through USB, providing us with USB flash drive to store the Python script and serial Python prompt for instant programming. This works with Windows, Macs and Linux. PyBoard execute MicroPython, which is lightweight implementation of standard C Python interpreter. The official documentation: MicroPython is a lean and efficient of Python C programming that includes small subset of Python standard library and optimized to run microcontroller in constant environment. The MicroPython board is a compact electronic circuit board that runs MicroPython on the bare metal, giving a low-level Pythonic operating system that can be used to control all kind of electronic project. MicroPython is packed full of advanced features such as interactive prompt, arbitrary precision engineer, closure list, comprehension generator, expansion handling, and more. Yet to be compact with fit and run with 256K of code space and 16K of RAM. So MicroPython is entire rewrite as Python version 3.4 programming language to fit and execute controller. It involves various optimization, efficiency, and consume liquids. MicroPython execute bare metal of PyBoard necessity providing the operating system based on Python. The inbuilt Py module consists of function and classes in order to control peripheral availability on the board like I2C, UART, ADC, DAC, and SPI. Another option could be ESP32 and ES to run on Python. We have to create a device-based Internet of Things with low power consumption, greater capability, and integration with wireless Wi-Fi network. More precisely, we can use MicroPython. Once we install Python, we will get the pip installer on the command line of ESP tool module. The syntax as shown. $pip install ESP tool. The installation procedure for MicroPython is easy, but we can download the firmware from the website and install in the help of tool. We can also use IDE for developing MicroPython. The complete procedure of development is carried out the working computer, then is compiled and saved in the ESP microcontroller. Example: importing the required module. Create an object pin, LED pin using the sum function while true, LED pin on, time sleep, LED pin off, time sleep. In this above snippet, we have imported pin module from the machine library along with time module. We have to create an object of pin and execute some function on it. MicroPython involves many restrictions compared to regular Python. However, in general, we can write the necessity functionality of the client code and execute it effectively ESP microcontroller. Understanding the Python aspect. So here we are using MBPT protocol with Python. One of the most connection method for IoT device is a protocol for effective implementation. MTQK protocol is machine-to-machine Internet of Things connectivity protocol designed in highly lightweight published messaging transfer. It is used to connect a remote location where a small code footprint is needed and network bandwidth is premium. Python client library called Eclipse Patho MQ implements version 3.1, 3.1, and 5.1. The code of Pogo library offer a client source that allow application to link in the broker in order to publish message. IoT backend Flash in Python. As we know that Frank Micro to framework to write the backend for IoT system. The Flash microframe is a quick and hassle-proof that easily server-side I/O information and also packed with many functionality. In severe case, there are off focusing on RESTful protocol which working with IoT device. This also allowed the exchange between the component of the system, help us to expand exchange information feature. The disadvantage of utilizing the method is potential lack of starting the data transfer from the server to the device. Thus, the IoT can periodically and independently pull the server. REST EC are the key component to report the risk. So Microsoft has released a new extension for IoT to extend the capability of Azure CLI 2.0, involve the command to interact with Azure management. For instance, we can utilize CLI 2.0 to build the Azure Virtual Machine or IoT Hub. The extension of IoT offers program command line to capability IoT Edge, IoT Hub, IoT Hub position, etc. So the new extension which features are Azure CLI 2.0, manage intention of IoT, manage instant of device promising things, new feature for extension, managing device and edge module, query IoT hubs for detail, invoking method for device model, generating a CS token, cloud to device, device filing, device simulation and testing, hacks of Python. Following some of the amazing hacks of Python: list comprehension following part, output expression, input sequence, a member of input sequence represented by variable, the optional predictive part. So consider the example we are having import tool of FT. First filter odd numbers, first filter lambda k, print this list. Then lambda of k filter, print odd square which is divisible by 5. Here we will have negative print filter lambda k less than 0. Now we can include max function, print maximum number in the list. So list will be, these are the list, odd square will divisible by 5. First filter negative numbers and maximum numbers in the list. Transpose of matrix of Python. Matrix nested with used, every element in the list is treated as row of the matrix. Print matrix 1 for row, resize it, print row, print matrix. The matrix will be 531398. It should be according to that, it will print it specifically. So this assessment question here, dash is the coding language that is to reduce the volume of data. So since MicroPython, dash method, get method will get the information. Dash MicroPython is a lean efficient implementation of Python 3 programming that includes small set of Python standard library and optimize to run the microcontroller in constrained environment. So these are all the basic question how we can implement Python using this tool. Thank you.